Hi everyone! Now we're at a lesson that's actually going to let us use our skills that we've been working on. So our essential question is, how can we model the path of an object using a quadratic function? So if we're considering the quadratic function shown in the table below, we notice that as our x values increase, our y values first increase and then they start to decrease. And that's exactly the picture of a quadratic function. Usually in a quadratic function, your x value is going to talk about your time, and the y value usually talks about your height, whether it's in feet or meters. So you have now two questions that are asked concerning this table. Please read the questions, decide what the answer is, pause the video, and when you're ready, please start playing the video again. All right, welcome back. Which of the following inequalities represents the range of a function? So if I'm talking about the range of a function, I'm looking at what the y values are. So when I look at this table of values, I notice that the y values go up and then they go down. And the highest y value is 11, which means all these other y values are less than or equal to 11, which is choice D. Okay, the next question, which of the following inequalities represents the interval for which the function is increasing? When you see the word interval, you know that we're talking about our x values. And we're looking for when the function is increasing. So once again, going to this table of values, this is when it starts increasing. And then it started to decrease. So when it was increasing, these are the x values that went along with it. And all these x values are at 1 or less than 1. Remember, when something we talk about is increasing or decreasing, we do not include the point where it starts or stops. So all these values go up to 1. That means that the x values are less than 1. Here's a great video to watch about parabolas in real life. So I'd like you to copy and paste that, watch it, and then when you're finished, please come back to our video. Okay, hope you enjoyed the video. Now we're going to talk about some questions you're asked about a parabola and a situation in real life. So when we're looking at a parabola, usually we're talking about an object that goes up in the air and then gravity forces the object down until it finally touches the ground. And that's going to involve three key points. We're either going to talk about our y-intercept, the initial height. We're going to talk about our vertex. When is it the highest it's going to go, and what is the highest amount? And then finally, we're going to look at the roots or the zeros of the object. When does it hit the ground? Okay, so if the question asks, when does an object reach its maximum height? We know the maximum height is going to be the vertex. And if it says when, we're looking about the time. So we're looking for the x value of the vertex. Well, how do we calculate that? Remember, to find the vertex, the x value of the vertex, we're going to take the part of the quadratic formula that is not underneath the radical sign, which is x equals negative b over 2a. And that will give us the x value of the vertex. You could be asked, what is the maximum height of the object? Again, you're going to look at the vertex. In this case, we're talking about the height, which is our y value. And how do we find that? Well, we first have to find the x value of the vertex. X equals negative b over 2a. And then what we'll do is we will substitute that x value into the equation to find the y value. Okay, how long is an object in the air? When does the object hit the ground? So how long and when is talking about the time. So we're looking for the x values. And when it hits the ground, we're looking for this spot, which is the roots or the zeros of the graph. And how do we find that? Well, when we have a root, we know that no matter where it hits the x-axis, the y value will be 0. So our first step is we set the equation equal to 0, and then we solve for x. And when you solve for x, you could either factor the AM method, GCF, or our fallback method, use the quadratic formula. If you can factor, that's going to be easier and more efficient, but if you can't, no worries, the quadratic formula will always work. Okay, your last question is, what is the initial height of the object? So the initial height is when you started, and our keyword is initial, which means we're looking for the y-intercept. And as long as the equation is in standard form, the y-intercept is going to be easy to see. It is going to be our c value, or the constant of that equation. All right, here's our first situation. The height of an object that's traveling through the air can be modeled by a quadratic function that opens downward. The object is first fired upward, and then gravity is going to push it down. And this is the formula that is showing what the situation would be. This is how the situation is modeled with this quadratic function. So you're asked to create a table of values and then draw a graph of the object's height for all times where the object is on or above the ground. First thing I want you to do is put this in your calculator, y equals. Take a look at the table of values and then decide what values for the input for t would make most sense in this situation. Pause the video and then come back to it when you have an idea. Okay, and we're back. So when you took a look at the table of values, you probably realized it wouldn't make sense for any x value to be less than 0 because time can't be negative. Also, taking a look at your table of values, when you reached 5 seconds, your h of t, your y value was 0. So it wouldn't make sense to have any more negative numbers. You wouldn't have negative height. So these are the x values that would make sense for the situation. And please take a moment to fill in the y values. Pause the video while you do so. Okay, and you took a look that when it was 0 seconds, this was 80 feet above the ground. And you notice as a quadratic function, it is going up, increasing, and now it's going down until finally the height is 0. And remember, we don't go any further because you cannot have negative height. So now what I'd like you to do is take these values, please graph it on this graph that's been given to you, and please remember all the details. Pause the video, and then when you're ready to check your work against mine, start the video again. All right, and this is what your graph should look like. You have the points plotted, and you have written the equation of the parabola right next to it. I have different colors on here for the reasons. Remember I talked about the 3 special points of a graph that we're usually looking at. This is your initial amount, your y-intercept. This is your vertex. In this case, this is the highest point that you're going. And this is where the graph intersects the x-axis, so the roots and the zeros. Now we're going to ask you some questions based on that. Okay, our first question is, what's the maximum height the object reaches in feet? Remember, when we're looking for the maximum height, we're looking for the vertex, and height is our y values. So we're looking for the y value of the vertex. In this case, we don't even have to do any algebraic work. We simply look at the vertex of this graph, and we realize that the y value of it is 144. And we can check that with the table of values. So 144 feet is the highest that this object reached. At what time does the object hit the ground? Well, hit the ground, I'm telling you that the height equals 0. So when this parabola in the graph shows that it hits the ground at 0 feet, it has taken 5 seconds for that object to hit the ground. State the domain and range of the function. Domain means we're talking about our x values. Range means we're talking about our y values. So looking at my domain, I'm saying, where did I start with my x values? Where did I finally end? You could look at it from the graph. You could look at it from the table. And for the domain, I could write it in inequality notation. 0 is less than or equal to x is less than or equal to 5. Or I could write it in interval notation. Bracket 0, comma 5, bracket. For the range, remember we always start with what's the lowest and then what's the highest. So what was the lowest height that you had? It was 0, remember when it hit the ground. And what was the highest? At 144 feet. You could check that with your table of values. Looking at your table of values, the lowest number was 0, and your highest number was 144. So in inequality notation, we say 0 is less than or equal to y is less than or equal to 144. And we could say bracket 0, comma 144, bracket. Over what time interval is the object's height decreasing? So time interval, we're only looking at our x values. And where is the height decreasing? So think of this as being on a roller coaster. You start, whenever we look at a graph, we read it from left to right. So if you're in a roller coaster car, you're going to go up, which means you're increasing. Then at the top, you sort of are suspended in air for a moment, and then you come down, and that would be decreasing. So where the height is decreasing is the amount shown in yellow here. Now you have a couple of ways to take a look at this. This is where it started to happen, at our vertex. So I'm going to write the coordinates of the vertex, 2, 144. And this is where it finally stopped, at 5, 0. Some people will say, okay, taking a look at here, I'm looking down over here. This is where I started. This is where I stopped. If you have a little difficulty seeing that, you could just look at the coordinates of each of these points. At the starting point, my x value was 2. At the stopping point, my x value was 5. So the height decreased when x was between 2 and 5. We do not include the starting point and we do not include the stopping point when we talk about increasing or decreasing. Remember, do not include the starting or stopping points. If we were going to include that, we would put an equal sign here, but we do not include it. Decreasing starts right after we've reached the vertex. Okay, last question. Over what time interval is the object's height increasing? Again, time interval, we're talking about the x values. In this case, the height increasing, we're looking at this orange section. So we know we started here at 0 and we ended here at 2. If you're not quite seeing this section, write the coordinates of this starting point, which was 0, 80. We know the coordinates of the ending point. And we're only looking at the x values because that's our time interval. So we started right after 0 is less than x, and we stopped at 2. And that would be the time interval for the object's height increasing. The second video will be giving you similar situations and talk about how to find something algebraically. So before you go on to that video, please make sure to review these first 2 pages and understand what part of the parabola that we're looking at.